Good morning and welcome to the blacksmith shop. This is where we make things out of iron and steel. Iron is an element, which means it can be found in the ground, and steel is iron that's had another element, carbon, added to it to make it a little harder and tougher. Now the first thing we have to do with both of these metals, because they're so hard and tough, we have to soften them up before we can work with them. To do that, I put it in a hot fire. And as I pull this handle, you can see that the bellows over here is operating. That blows air in the fire, and the fire then gets a lot hotter because of the additional oxygen. This fire can reach temperatures in excess of 3,000 degrees Fahrenheit, and we don't want to let the steel get quite that hot because it would burn up just like a 4th of July sparkler. What we're looking for here is a temperature of about 2,000 degrees Fahrenheit, and I'll know when it gets there by the color of the metal. It's going to be a bright yellow like it is right here. Now the first thing that I'm going to make is a nail, and this is the way they used to make nails to build the houses with a long time ago. Currently we have machines that can make about 5,000 nails a minute, but back in the day if you could make 2 or 3 nails a minute you were doing really well. I started by hammering a point on the end of the bar, and now I'm making a taper the length that I want the nail to be. Once that taper is established, I'm going to cut most of the way through the bar by hammering it over a tool called a cut-off hardy. Then I put it in this handle called a nail header. The bar goes back in the fire for the next project. I put the point of the nail down through a hole in my anvil and start to strike the blunt end with my hammer. Because it's tapered, it won't go all the way through the nail header, and therefore it gets stuck. Once it gets stuck, as I continue to hammer, the metal flattens out and becomes the nail head. After quenching it in water, it becomes cool enough that I can handle it with my bare hand. And I'll set it right over there. Now, a minute ago when I cut the nail off of that bar, I stuck the bar back in the fire, and even though I haven't pumped the bellows anymore, by now the end of this bar is up to 1,800 degrees Fahrenheit, which makes it very soft and easy to bend. I can bend it around in a complete circle using only one finger, and if I know how and where to hit it with my hammer, I can make all kinds of crazy shapes with it. I can make letters and numbers and symbols. I can actually even tie it in a knot, which is what I'm doing right here in front of your eyes. I just use different parts of the anvil to hold the work still while I can get it all shaped and tightened up the way I want it. And you can see that here we have a knot tied in a piece of steel. Now in order to cut that off, I'll change tools once again, put the cut-off hardy back in the anvil, and I just hammer a couple of times over that. And once the steel has cooled down to the point it is now where you can't see any more red color in it, it gets to what we call a black heat. It's still too hot to touch with your bare hands, but it's brittle and easy to break. I'll just put that in a tin can full of melted beeswax, and that will protect it from rust and put a nice shiny black finish on it. A lot of people ask me if I shoe horses. All the old blacksmiths did. I shoe no horses in my business. I don't get along well with them, and they're big enough to hurt you. So instead of that, the only thing that I shoe is a baby unicorn if it's not over knee high. And this is how I make shoes for them. It's very similar to the process for making full-size horseshoes, but the advantage of it is when I'm doing a show for little kids, they don't have to pay attention for as long. This is going to take me about 5 minutes versus about 40 minutes it would take me to make a proper horseshoe. And yes, farriers, the guys that regularly make horseshoes, can do it a lot faster. But since I don't do this often, I'm slow. First thing I did was to take a heat on the end of the bar to 2,000 degrees. I'm going to bend that over a little bit and fold it over on itself so that the end of the bar is now thicker than the rest of the bar. Once I have that thick place to work with, I can shape that into a little bit of a point. It's not very long, not very sharp. It's just enough to stick down in the ground a tiny bit, like a cleat on an athletic shoe, and we call that a heel cock. You won't find heel cocks on every horseshoe, mostly on horses that have to pull wagons and farm equipment and stuff like that. But if you find one heel cock, you have to have two in order to keep the shoe balanced so that the animal doesn't go lame. So I'm heating up the second end of the bar, and it shouldn't take nearly as long to heat up the second time as it did the first time. The big trick is finding it in that cold fire. Needs just a few more seconds in the fire to reach 2,000 degrees. And here we are. Once again, I'm going to bend it down and fold it over, and then shape it into a heel cock. Now that I have heel cocks on both ends, it still doesn't look much like a horseshoe because it's still a straight line. So I'll put it back in the fire one last time, and on this last heat I'll do everything else that needs to be done to make it look like a horseshoe. Need to make sure I've got all the right tools handy because the heat doesn't last very long. I've got maybe half a minute from when I come out of the fire until I have to be done. So I'm also going to put on a leather glove in case I get a little too close to my work. It won't be as bad for me. This heat is a little uneven. I'm going to turn the ends, put the cooler end in the middle of the fire for about 4 or 5 seconds, and that should even up the heat. Now I bring the shoe to my bending jig, and I'm just going to pull it right around and bend it, and then I'll use my hammer to tighten up the ends. And there it is, shaped just like a little tiny horseshoe. I'll clean it off with a wire brush to remove scale, which is made of burned up steel. If you don't get the scale off, little bits of it can come loose and get on you, and if they get on your clothes, they'll burn holes. If they get on your skin, they'll make blisters. Neither one is very much fun. I make sure the shoe is flat by hammering it on top of the anvil. And the last thing to do is to put in the nail holes. To do that, those holes are punched in the bottom of a crease. In the unicorn shoe version, in order to save time, I don't bother with the crease and I don't put the holes all the way through. But I've got a tool here that I made that can mark the positions of 3 nail holes at once. And when I get done with it, I have a finished baby unicorn shoe. Now, just to make sure that this doesn't rust and to enhance the color a little bit, I put it in melted wax, and in a few minutes when it's cooled off, I'll have a nice pretty souvenir that I can show. And that's also a popular product when I'm doing shows for kids. All right, to get back to something a little more useful, let me just make an S hook. And I have the right tools at the anvil. So I'll start with a short piece of 1/4-inch square bar, put it in the fire, and I'm going to take a 2,000 degree heat on the end for several inches. And depending on how well the fire is burning, that can take just a few seconds, or it can take up to a minute or so. A little deeper in the fire there. Now once I've got a good heat on the end of the bar, I'm going to taper the end, and I hammer it a little bit on one side and then I turn it 90 degrees and hammer it on the other side. Meanwhile, every hammer blow, the anvil is returning force from the other side. So it's like hitting it on two opposite sides at once. Once I have this taper on the end of the bar, I'm going to curl it around in a little curl so that nobody gets stuck on the point. The whole reason for tapering it is just because it looks better to the human eye. So then I'll put it in my bending jig again, and I'll bend it, and here I have 180 degree bend. One side of that hook is already made. Now I'm going to put this back in the fire and do the other end. And while that's heating up, I'm going to get a different pair of tongs. Shouldn't take as long to heat it up on the second heat as it did on the first heat, just because of the residual heat that's left in the piece. And here we are, hot again. So once again, I'm going to taper the end. And smooth up my hammer marks a little bit. Then I'll curl the end. And take it to the bending jig and bend the second end of the hook. At this point it's fully functional, but I like to put a little bit of decoration in my work. You know, prior to the Industrial Revolution, all hardware had a certain element of art to it. And that's something that we lost whenever we went to mass production. So I'm trying to bring that back a little bit in my work. Therefore, I'm going to heat the center section of this between the two crooks of the hook, and I'm just going to put a decorative twist in there just because it looks good and because I can. This time I don't need to be quite as hot. 1800 degrees is plenty for a twist. But it's important that the entire portion that I'm twisting and a little bit beyond on both ends of the twist be at a consistent temperature. That way I get a nice even twist to it. For some reason, it doesn't seem to want to do right here. Make a little more coal over top of the fire. Should help hold the heat in the middle. And at this point it should be ready to come out and twist, and here we are. So I'll take it to the vise, and I'm going to put it in the vise so that the end of one hook is just even with the edge of the vise jaws. Then I put my twisting wrench even with the end of the other hook. I'm going to rotate it exactly one revolution. At that point I've got a nice twist in it. Now, well, this vise did not grab it properly this time. I've got a really interesting phenomenon here of a twist that goes all the way from here to here where it was supposed to stop here. Never know what's coming next. I think in order to make that look right, I'll put it back in the fire and put some extra twist on the other end as well. Go. Now, and that is how we make a mid-course design change. I have a little bit of an unintentional bend here besides the twist, and I'll squeeze that out using the vise jaws so that I don't have to hammer it out. because hammering it out could knock down the corners of that twist and it wouldn't be as visible. Now I'll just wire brush this whole thing and put a coat of beeswax on it, and the beeswax will protect it from rust and also enhance the color a little bit. Before I get to waxing it, I'm going to just tap it enough to straighten it up, get it all in one plane, so to speak. And then the hard part is remembering that it's still too hot to touch, even though it looks cool. So I put it in this can of wax, and the can isn't deep enough to dip the whole thing at once, so I have to switch ends. And here we have the finished piece, ready to just let it hang up and cool. All right. I've been doing these public demonstrations for a little over 20 years now, and it never gets old because there's always somebody coming up with a different question, or I do a lot of shows for school children on field trips, and it's interesting to see what they think of the work. Some of them are totally unimpressed because it doesn't have enough megabytes of RAM in the hammer. And others think that it's magic. I kind of agree with them. It is magic. It's the magic of physics. That's something that I didn't think about when I was a kid in school. I thought, well, why do I need to study math and science? I'm not going to be a scientist. And here, every day of my life, I have to use math. I have to use geometry to figure out how long a piece to cut if I want to make a circle. I have to use physics just to know how hot the metal is, how soft it is, where to hit it, how hard to hit it, stuff like that. Didn't have any formal training in physics. I like to tell people most of what I know about geometry and physics I learned on a pool table. But that's just kind of one of the methods we learn by. Probably easier to learn it in school. All right. Get this tightly in the vise, and one full revolution, and we have a nice pretty little twist right in the middle of the shaft of that hook. So now I just press the kinks out of it. And I can clean it off with my wire brush and put a wax finish on it. All right, a little bit of wax on there. And we have another finished product. Just hang that up to cool a little while. Meanwhile, this other one has cooled off enough that I can remove the drips. Sometimes you get a little more wax than you actually need. And there we go. Let's see, I had a piece of steel down here. This is just a piece of 3/8 inch square bar. And I can make that into a leaf. The first thing I'm going to do is take a 2,000-degree heat on the end of it. And while I'm doing that, I'm going to get rid of some tools I don't need and get the right tools that I do need. This will take just a little bit longer to heat up than what I was working with a minute ago because it's got about twice the mass. But it still doesn't take real long in a good hot fire. Get a little more fuel in here. Just about hot enough now. And the first thing that I'll do is hammer a point on the end of this bar, just like I did a while ago when I was making a nail. Now I'm going to take it on the corner of the anvil and I'm going to make an indentation on two sides that will separate a little pyramidal mass on the end from the rest of the bar. And here we have just a little piece on the end that's kind of a taper, and then there's a thin place. I'll take another heat on it, and on the next heat this is going to start to look like a leaf a little bit. Almost hot. I want this good and hot this time because I've got a lot to do. I'm going to take that square taper on the end and flatten it out into kind of a spade shape and give it the general shape of the leaf. By just doing a slight variation on this, I can make it into several different kinds of leaves, or I can make arrowheads, or whatever I want to do with it. I've got a little bit of heat left over, so I'm going to start to stretch out the stem portion just a little right now. I don't want to get it too thin yet so that I would break it off before I'm ready. And now once it's spread out, what's left over of the heat at the very end, I can use a chisel. And that wasn't a chisel. I can use a chisel to put the veins in the leaf. This is called a walking chisel. It's got a slight curve on the edge so that I can rock it as I'm moving down a line, and I can leave one end of it in the line at the end of wherever I stop chiseling and move the other end down and just continue to take one step after another. And the veins, as in nature, can either be exactly opposite each other or they can be staggered. I choose to make usually 5 veins down each side opposite each other. On the next heat, I'm going to cut it loose from the bar and start to draw out the stem. So in order to do that, I'll put a cut-off hardy in the hardy hole. And I'm going to need another pair of tongs to catch the leaf when it comes loose. This is a stage where it's kind of tricky because the part that's the blade of the leaf is much thinner than the rest of the bar, and I have to get that bar hot enough that I can cut it off without burning up the thinner portion that is the blade of the leaf. Meanwhile, these little sparks keep landing on my hand and trying to bite me. All right, I'll lay this over the hardy and hit it a couple of licks and turn it. And that cut right off. Now I'll use these other tongs to hold it. And we can see that it's cooling off quite a bit already. So I won't get a lot stretched out on the stem on this heat. Try to make it round to start with. The end of the bar tends to split. So at this point I'm working with a really thin piece of metal, and I'm going to change hammers to a lighter one. A little easier to control what I'm doing that way. I'll leave a small wider area at the very end of the stem, and then I'm just going to round up the rest of it and get it pretty thin. Now I'll bend it over so that when I bend it around in loop in a minute, the loop will be centered over the blade of the leaf. And I will need scrolling tongs for that. Put this right here in the vise, and using the scrolling tongs I can bend this loop around like this. Take it back to the anvil and just flatten that into one plane. Now I have a piece that looks a whole lot like a leaf, except that it looks like a leaf that's been pressed in a book, because you can see that it's really flat. So what I'll do now is take one more heat. On this last heat, I'm going to do two things. The first thing I'll do is put my signature on it so that everybody will know who made this piece. And then I'm going to give it some volume and texture so that it looks like it's still alive. So first off, I have to find my little touch mark stamp, which has got my logo on it. And I'll get that right there in a good spot. Bring my leaf up to at least a bright orange temperature. And then I can drop that on the anvil, hit it with the touch mark. And then I bring it to this little round hole in the anvil, and I'm going to use the ball peen hammer to kind of give it a little bit of shape and texture. And finally, clean it with a wire brush and wax it. Put it in some wax. Put the other end in the wax. And now it's protected from rust. I can cool it off so that that wax doesn't burn off too much. Clean it up one final time with the brush. And this piece is ready to start its working life as whatever it's going to be. In this case, I think I'll make it into a keychain. So I'll take a little keychain ring, put that through the loop, and there we have a little keychain that's got my signature on the back. And there it is. So that's kind of what I do in the blacksmith shop.